So welcome to today's short online seminar on data management, on Let's Make Research Data Fair. I'm Julie Goldman, Research Data Services Librarian at Countway Library. And as a note, this session is being recorded and you'll receive a notification when the recording and the slides are available to you. Our publishing and data services team at Countway is here to help. We offer workshops, tutorials, and consultations on workflows and tools for scholarly communication, research collaboration, data management, and bioinformatics. Additionally, the Longwood Medical Area research data management work resources, this work is element community, information, research shooting, research scores, and just you bookmark this website and reference it as needed. So let's review today's learning objectives. You'll understand FAIR principles for research data. You'll understand how data management practices enable FAIR data. And I've already provided some help at Countway Library for you to contact for assistance. To start, let's define research data management, as this will set up our FAIR principles. So research data management concerns the organization of data from its entry to the research cycle through the dissemination and archiving of valuable results. It aims to ensure reliable verification of results and permits new and innovative research building on existing information. And here are some reasons why data management is important. There are benefits for yourself, other researchers, and science in general. First, your future self will thank you. You think you may remember the arcane system you had of naming files, but next week or next year, it will probably have slipped your mind. So documenting your system is very important. And data management facilitates and ensures seamless team transitions. It allows everyone to focus on the research and the science instead of spending time trying to decipher those file names and locations. Data management enables you to conduct analyses effectively when collaborating with others, and also enables others to replicate your work or conduct new analyses. And when well-documented reagents, protocols, and data sets are available, this facilitates data reuse and increases the visibility of research, therefore allowing you and others to check and verify research results. And managing data supports our FAIR principles, making data findable, accessible, interoperable, and reusable, which we are going to cover in more detail in this session. And additionally, there is a movement among sponsors to require the data sets that underlie research funded by the public to be made available. So we want to make sure we are compliant with university and school policies, funding organizations that require a data management plan and data sharing, and also journals that require you to submit your data accompanying the article. So if you have attended our other research data seminars, you know we like to provide some iteration of the research, data, or project lifecycle. The research lifecycle provides a high-level overview of the stages involved in successful management and preservation of data. Having an idea of the overview of the research process help us understand the steps and activities involved and break them out in more detail. So the diagram on the slide shows how we might work with traditional scholarly resources through a project. First, we gather primary sources or collections from the library or databases. Our research project includes elements such as a grant proposal, research questions, methods, collecting data, and performing analysis. This leads to the publication of reports and journal articles, which are shared in institutional repositories and available from databases like PubMed, enabling the cycle to continue. So next, we can see how research data fits into the research lifecycle, like our other scholarly resources. Published data sets can help with our discovery and planning phase. Through our research, we may create new data sets and use and develop code. And these new outputs, the data sets and code, can be considered unique research products as well. Therefore, we want to make these available in data repositories in order for others to be able to find them. However, it is not only about discovery of these data sets and associated files. So as a researcher, you need, as I just mentioned, to be able to find the data within a repository. Publication should include the data citation that identifies the repository where the data is located with the use of persistent identifiers. But there are a few other things researchers need. You need the data to be accessible. This means you can obtain the data with minimal effort. And even if the data is restricted, the metadata is can request further access. The data should be in an appropriate format using common formats and standards and controlled vocabularies. This ensures you can integrate a new data set with other data. And lastly, you need the data to be well documented and have clear usage language. Upon a first review, you should be able to determine how you could use the data and again, accurately understand the content of the data set. And each of these 4 elements that a researcher needs to discover and reuse data leads to the creation of the FAIR data principles. So the FAIR data principles are a set of guiding principles stating all research objects should be findable, accessible, interoperable, and reusable, both for machines and people. And these principles provide guidance for data management and data stewardship and are relevant to all stakeholders in the current research ecosystem. So good data management is not a goal in itself, but rather it is a key element ensuring data is discovered and reused by the research community. I'm just going to provide a little bit of background of the FAIR data principles. In 2014, an international group of stakeholders came together during a workshop surrounding the theme of how we could more easily discover, access, interoperate, and properly reuse the vast quantities of research of information being generated by contemporary data-intensive science. And these simple principles and practices for scientific data management and stewardship, coined FAIR, were published in a 2016 article in Scientific Data. They are technology agnostic and discipline independent. The FAIR principles describe how research outputs should be organized and documented so they can be more easily accessed, understood, exchanged, and reused. And the principles emphasize machine actionability to optimize data sharing and reuse by both humans and machines. So next we will go through each of the 4 elements and explore how to implement them and make your data fair. First, findable. Data, as well as the metadata describing them, should have globally unique and persistent machine readable identifiers. Make your data findable by ensuring it has a persistent identifier, has rich metadata, and is searchable and discoverable online. And the metadata describing your data supports this findability, citation, and reuse. So you need to ensure your data have persistent identifiers, or PIDs. And PIDs are important because they help identify your data and facilitate data citation. An example of a PID is a digital object identifier, or a DOI, commonly used in citing research articles. And when depositing your data in a repository, you should make sure to select a repository that assigns a persistent identifier, for example, Dataverse. And rich metadata provides important context for the interpretation of your data and makes it easier for machines to conduct automated analysis. So make sure to follow standard metadata schemes and a general one, such as Dublin Core, or there are discipline-specific standards and schemas out there. Second, accessible. Data and metadata should be retrievable via identifiers with standardized protocol that incorporates authentication and authorization procedures. So make your data accessible by ensuring it is in a reliable storage location, such as a repository, is retrievable online using standardized protocols, has restrictions in place if necessary. So remember that not all data has to be made open. Data can be restricted and still be fair. However, if access is allowed, data should be retrievable without the need for a specialized process. So depending on the type of data you have, sometimes you are unable to make it completely open. So remember this rule of thumb: as open as possible, as closed as necessary. And the technical infrastructure of a data repository will enable this accessibility. And you should look for a repository that does the following: stores the data safely, make sure the data is findable, describes the data appropriately with metadata, and adds license information. And you can deposit data to a general repository like Zenodo or Harvard Dataverse, or a subject-specific repository like Geo or Dryad. Next, interoperable. So data and metadata should be formatted in formal, shared, and broadly applicable languages that includes cross-references to other metadata and their relationships. And make your data interoperable by using common formats and standards, formats that are open and standard where possible, utilize controlled vocabularies, and formats should observe good preservation practices. Interoperable data means it can be integrated with other data, applications, and workflows. And again, the technical infrastructure of a data repository will help ensure you report and include the relevant metadata in appropriate standards. And from the start of your project, you should think about making data available in open formats. If you have to capture data with proprietary software, take time to determine if data can be transformed into more open and interoperable formats. Additionally, remember to use community-agreed schemas, controlled vocabularies, keywords, thesauri, or ontologies where possible. In common standards, we see our medical subject headings, or MESH. SNOMED is a comprehensive clinical terminology standard for clinical documentation. And the International Organization for Standardization, or ISO, supports various standards for such things as date formats and information security. And lastly, reusable. So data and metadata should be described thoroughly enough so that they can be replicated and combined in different settings. You can make your data reusable by ensuring it is well documented, has clear terms of use, and has clear license and provenance information. You should create documentation in a README file to help ensure that your data can be correctly interpreted and reanalyzed by others. So a README plain text file should contain some of the following information. So for each file name, a short description of what data includes, optionally describing the relationship to the tables, figures, or sections within an accompanying publication. And for tabular data, include definitions of column headings and row labels, data codes, including any missing data, and measurement units. Your README should include any data processing steps, especially if they are not described in the publication, since these may affect interpretation of results. Also include a description of associated data sets that are stored elsewhere, and importantly, include who to contact with any questions. And if text formatting is important to your README, a PDF format could also be used, but the text format really ensures that anyone could access it on any platform. And this README should be published alongside your data sets. So the last piece to make our data fully reusable are policy and usage rights. Data should have a clear license to govern the terms of its reuse. So along with our documentation, it is recommended to use Creative Commons 0 or Creative Commons BY as a straightforward and effective way to make it possible for others to mine, exploit, and reproduce the data. But of course, there are other types of licenses beyond the Creative Commons for data and code. And I have provided a link to a license selector wizard, which can help you choose an appropriate license. So throughout our exploration of each of the 4 elements of FAIR, Findable, Accessible, Interoperable, and Reusable, we have seen how data repositories facilitate and enable data to be fair. Repositories are databases containing well-described and well-documented research data sets. A good repository will help make your data more valuable for current and future research. It will help you organize and deposit your data and provide a means for and help the data to be cited, discovered, and preserved over the long term. And the technical infrastructure of repositories helps support and implement these FAIR data principles. FAIR enabling repositories allow for data to be restricted, but citation and metadata always publicly accessible. They generate DOIs automatically, provide attribution to data authors, and register the dataset record to a global index so that others can search and discover it. Repositories should support domain-specific descriptive metadata and variable and file metadata. Additionally, use of, say, APIs and standards ensure open and interoperable data and workflows. And lastly, fair enabling repositories also provide access and usage controls. Again, data may be open as a default with CC0 waivers and custom terms of use and licenses when needed. So let's summarize the FAIR data principles. As we saw in our beginning research workflow, we see that data should be considered a scholarly resource we want to use throughout the research process. Therefore, we need to be able to discover, understand, and use the data products we and others create. FAIR data means data is findable to increase visibility, citations, and impact of research, and support knowledge discovery and innovation. Accessible in order to streamline and maximize ability to build upon previous research results and foster partnerships with other researchers. Interoperable to promote use and reuse of data, allowing resources to be allocated wisely and improve reproducibility and reliability of research results. And FAIR data is reusable to support and promote inter and cross-disciplinary data and reuse. So I hope you have learned about the FAIR data principles and some strategies for applying the principles, enabling your data to meet these guidelines. Some quick takeaways from today's webinar include, again, FAIR refers to findable, accessible, interoperable, and reusable. It makes data available fair to not only humans, but also machines. These principles apply at each stage of the research data lifecycle and serve to increase the value of data as a scholarly resource. The intent is that these may act as guidance for those wishing to enhance the reusability of their data. The FAIR data principles are becoming widely used within the data management and data sharing community and the standard in funders' requirements. And remember, good data management facilitates and is an important first step to making your data fair. Specifically, the quality of data documentation and metadata becomes vital in order to meet all four principles. Here are some additional resources for the FAIR data principles I encourage you to explore. I've included a checklist you can use to evaluate your research data and what measures could be taken to improve fairness. And again, you will receive notification when the recording and slides are available, so these links will be more accessible to you. Please see this website for more on all of the topics we discussed in today's webinar, and submit any questions and feedback using the online form. We have one more upcoming webinar in April, so be sure to register at the link provided on the slide, and look for more seminars in May. Our first one will be on metadata, and we'll expand on some of the concepts we touched on today. So thank you for joining us today. We hope this webinar was useful to you. We would appreciate your feedback and any topics you would like to see presented in the future. So please fill out the survey at the link provided.